Hello everyone, you're welcome to yet another edition of OS e-learning platform brought to you by OPERO Stephen, actually taking you through the tutorial of physics today, and in particular the theme Earth and Space Physics. We want to discover much about the mystery of the Earth and the space science, and today's discussion is dwelling or zeroing so much on the sea or the ocean tides. What actually causes the ocean or sea tides? But what are these tides all about? Tides are periodic rise and fall in the level of water in large bodies like oceans and seas. Tides are caused primarily due to the gravitational pull or force of the moon on the earth. This generates tidal force, which causes the earth and its water bulge out on the side of the moon. Another bulge occurs on the opposite side, since the Earth is always pulled towards the moon away from the water body on the far end or side. These bulges are what we call high tides. High tides. The side of the Earth that are not facing the moon experiences low tides, and high tides and low tides are the regular rise and fall of the ocean water levels, primarily caused by the gravitational pull of the moon and to a lesser extent the sun. On the earth's oceans, resulting in bulges of water on opposite sides of the planet. So we get to realize that the earth experiences two forces, that is that on the sun and the earth, and also the moon and the earth, though for that of gravitational pull due to the sun is so less that it can't be felt, so that is why it is of a lesser extent. And given the fact that its distance from the earth is really too big, that it gives no manifestation of the gravitational pull. However, the distance between the earth and the moon is quite small compared to that of the sun, and therefore the gravitational force or pull due to the earth and the moon is felt for the case of the moon and the earth. So the moon greatly affects the occurrence of tides, that is the high tides and the low tides. So we have the lunar cycle and tides. As the earth rotates, different regions pass through these bulges, leading to the cyclo pattern of rising and falling tides. So how is the sun affecting this tide? The sun also exerts a gravitational pull on the earth, but its effect on the tides is less pronounced than the moon's effect due to the sun's greater distance. So there is what we call the spring season. So the spring and the nip tides. When the earth, sun, and the moon are in a straight line or are aligned during new and full moons, their combined gravitational pull creates spring tides with the largest tidal range. Tidal range refers to the difference between high and low tide. When the sun and the moon are at right angles to each other, that's during the first and the third quarter moons, their gravitational forces partially cancel each other out, resulting in nip tides with the smallest tidal range. So the advantages and disadvantages of tides. Tides can be helpful in the following ways. 1. High tides help in navigation over the oceans or sea. Tides bring more fish close to the shores for the men or the fishermen. Tides can be used to generate electricity, most especially high tides. However, on the other hand, they are very, very dangerous to to human life and also the marines. And so the dangers are here. 1, they cause floods for the people living near the shores. On the other hand, they also cause accidents and probably death to people living within the vicinity. Tides cause coastal erosion, destroying the habitats and disrupting marine ecosystem. Lastly, it increases the risks of pollution, and particularly water pollution. So let's get into the illustrations of the tides, the high and low tides. So we agreed that this happens when the lake shores or sea shores experience that periodic rise and drop or fall in the level of water. So the question is, does it happen all the time? Or it is just momentarily? Another question is, does the earth actually rotate? And if the earth rotates, then the high and low tides do happen every time, every day. So let's get into this illustration and we see the mystery of science, the mystery of the creation of the world, the universe. I mean, the space science, the space physics, Earth and space physics. So, from the illustration, we can see that the Earth experiences surely 4 tides, 2 of the same caliber on opposite ends, and most especially that side that receives the gravitational pull from the moon, and the other side that do not experience the moon, they count as what we call the low tides. High probably means big. If you check on the curve formed or the swollen size of the water or the surface of the earth between the moon and the earth is quite big, and also it is the opposite side compared to the side that's not experiencing the gravitational pull or gravitational force on the earth due to the moon. So let's have a look at this. We can clearly see that there's that periodic rise and there's that periodic drop in the level of water, and all is brought by the fact of gravity. As the earth rotates on its axis, Between the Earth and the Moon, there is gravity on the Moon due to the Earth, and on the Earth due to the Moon. Given that the Earth is taken up by the biggest percentage of water, it is actually the water that experiences this gravitational attraction. So the Moon pulls the Earth at the same time the Earth pulls the Moon. So by the end of the day, it is the water surface that is pulled towards the Moon, giving a swollen curve, what we call the bulges. These take place in such a way that one end is big and the other end apparently is small. So the bigger end is the one we call the high tides. Then the smaller end is what we call the lower tides. Now, the truth is for 24 hours, the Earth experiences high tides on its opposite ends and also low tides on its opposite end, and most especially that end that is not experiencing gravitational pull due to the Moon. So the question is, do you think the Earth experiences the four tides? Yes, that is the answer. And here is the illustration. Considering the three parts of the Earth, and I'm taking consideration of the side that is facing the Moon, you get to realize that side A will greatly experience that gravitational pull on the Earth due to the Moon. And then the Earth will be moved to encounter the force towards the Moon, meaning part C will be left with some space of a bigger volume of water. Are we together? So you got to realize that between B and C and B and A, we get to realize that those points experience what we call high tides. But now, since the ocean tries to counter or to occupy the remaining space, it reduces and gives a smaller tide on the opposite side, on the other side of the Earth that is not experiencing the Moon. So by the end of the day, we get to realize that the Earth experiences high tides on its opposite ends for that side that is experiencing the Moon's gravitation pull or force, and then the other side that is not experiencing the Moon's gravitational pull experiences what we call low tides. So by the end of the day, the Earth experiences the four tides, high on the opposite ends and also low on the other end that's not receiving the gravitational pull. Now, since the Moon is on constant motion, so these tides keep on shifting position as the Earth also rotates. So in the first presentation, we agreed that the Earth rotates on its axis that brings about the day and night aspect. However, its rotation also affects the tide. Its rotation affects the tides formed on the sea levels or the oceans. So we get to realize that basically tides, in summary, are the high and the low levels of water. So when there is that increase in the sea level, that's what we call the high tides. And when there is a drop in the sea level, that's what we call the low